Hello there, my fellow countrymen. What you are about to witness is not merely luck, but an application of mathematics in understanding the projectile motion. As Isaac Newton once said, what goes up must come down. And so does kaedeharayamamoto. We know that it is due to the impact of gravity. But let's consider this problem mathematically. Gravity is a force. And according to Newton's second law of motion, force is equal to mass times acceleration. So the gravity applied on the mora is equal to its mass times gravitational acceleration. Now, since every object is constantly under the impact of gravity, it's safe to claim that the mora is always accelerated. This explained why the mora's velocity decreases constantly, until the mora reaches the maximum height and falls down. Exactly, acceleration is the rate of change of velocity. And luckily people has figured out their relationship. If we choose the recorded moment when the mora reaches the highest, its current velocity is absolute zero. As a result, we can write the equation like this, with capitalized T as the total time. To complete the whole trajectory, we shall conduct the equation as below. Note this equation down because, my dear fellow countrymen, we will use it later. All right, now what if the mora has another initial velocity, but horizontally? Think about it. What is the combination of horizontal motion and vertical motion? Obviously, the mora's trajectory will become a parabol, which looks pretty familiar, isn't it? In ideal condition, the projectile's trajectory is under the influence of vertical velocity, which we mentioned before, and horizontal velocity. Note that the object's horizontal velocity remains constant, as there's no external force except gravity, which only affects vertically.
That the velocity in the x direction throughout this whole trajectory, if there is no air drag, if there is no friction, is not changing. It's only the velocity in the y direction that is changing. It means if I throw up this golf ball, I throw it up like this, and it has a certain component in x direction, a certain velocity. If I move myself with exactly that same velocity, with exactly the same horizontal velocity, I could catch the ball here. You ready for this? You ready? Yes. I'm ready. Physics works.
Since the horizontal velocity remains stable, we are able to conduct an equation with d as displacement. Also, we've already figured out the vertical velocity. These two are the components of the initial velocity v, and is the aiming angle, so that Ganyu's arrow can reach the target position. Angle of reach is the angle that, given an initial velocity v, a projectile must be launched in order to go a distance d. With our conclusions previously, and basic knowledge of trigonometry, we should be able to figure out the relationship between the angle of reach, David's gravitational acceleration, the distance, and initial velocity. Because gravitational acceleration and initial speed are fixed as default in Genshin impact, we can consider those two as a single constant. So our next objective is to find out the value of x. Of course, with given angle of reach and distance. Good news, David continent is flat and the sky is a hemisphere. So you can approximately adjust aiming angle based on the location of the sun. In this example, my angle of reach is 15 degrees. Remember to mark your arrow's landing point. Bad news, our map does not have coordinate system. So we will rely on the Tavit interactive map provided by Hoyoverse. I will mark these 2 points, so that I should be able to have a fixed coordinate unit. Now, my dear fellow countrymen, it's time to grab your rulers. Measure the distance and the coordinate unit. Do not zoom, because that will make the map's scale become inconsistent. These are the measurements in my example, which eventually lead to the final result. This equation will be accurate, as long as you use the Tavit interactive map coordinate system.
Good opinion. But what if the target locates at the higher ground?
Well, I did think about that problem, but no need to worry. Currently, I am trying to figure it out, and the answer should be in the next video. For now, we shall depart, my dear fellow countrymen. We will see each other in the near future.